Hello students, how are you? Hope you are well, and after long days we are again meeting in SB Maths class. So welcome to SB Maths class again. Today we will discuss about the laws of algebra of set. And that is in previous two videos we have seen, that is the basic concepts of the set theory and also some definitions and also some operations on set theory. So let us today discuss about the laws of algebra of sets. So let us start. Laws of algebra of sets. So what we will discuss here, that is for doing the operations, what the laws are required. Some special laws are there on set theory. We will discuss about those, and also I will write those here. I suggest you to just go through those laws and also try to apply those laws in the numericals, what you will find at your books, R.D. Sharma or R.S. Agrawal, whatever you have with you. And if you have any problem, then you will ask me. The first law, idempotent law. You have to memorize those names. Idempotent law. What is the idempotent law? Very simple. A union A. If A is a set actually, then A union A equals to A. That is number 1. Number 2, A meet A equals to A. Actually this is called union, this is intersection, sometimes this is called as meet. This is a very useful law and also very easy law. That is, if you take union of one set with that set only, then you will get only that set, because in a set you cannot repeat the terms. So if the set is 1, 2, if the elements are 1, 2, so 1, 2 union 1, 2, that means 1, 2 only. And intersection means the common parts. So in that set, that elements will be common with that set only. So obviously A union A equals to A and A intersection A equals to A. This is very easy rule. Number 2, the identity law. Actually, two identities are there. For union, one identity is there. For intersection, another identity is there. You know from the previous classes, class 9, class 10, you know what are the identities. That is multiplicative identity, that is 1 only. And the additive identity, that is 0 only. That means for additive identity, A plus 0, A is a number, A plus 0 equals to A. That means whatever the identity, if you do that operation with one number, then you will get that number only. For multiplicative also, A into 1 equals to A, that is the identity. The rule of identity is that one. Here for union, if we take A union phi, that is the null set. If we take A union phi, that means the elements of the set A union the elements of a void set or null set, that is nothing. That means we are getting only that set only. A union phi, that is the null set, equals to A. And for intersection, A intersection U, that is the universal set, that is also equals to A. Universal set means the collection of all the sets under the operation. So all those things are here. Now we are taking common between the set A and also the universal set. So in the universal set A is also there, so common will be only that set only. So that's why A intersection universal set equals to A. So for union identity, if you say like that, for union identity phi is the identity element, and for intersection universal set is the identity element. Number 3, commutative law. You are well known about this law, how to do, what are the operations, what are the rules of this law, you know. So if A and B are two sets, then A union B equals to B union A, and number 2, A intersection B equals to B intersection A. Very easy rule, nothing to describe here. Number 4, associative law. Associative law in the number system, we know that is we have to form the group and that group will associate with others. So here A union B union C equals to, we can write A union B union C. Same as for the intersection, A intersection B intersection C, we can write A intersection B intersection C. Those are the rules only. We have not completed, just we have reached the end of the board, that's why I have only paused the rules. I will write later. So those are some rules only. What the need of those rules? Actually, need of those rules means it has higher aspects, lots of uses are there. I am not coming there now. Lots of numericals you will see, lots of uses are there, applications are there, you will do later. But actually sometimes if you take any sets, A, B, C, any sets, then you can verify those laws, that is those will support, those will satisfy by those sets only. And sometimes the question comes like that, that is some sets will be given to you in the exam paper and then you will be asked that is verify this law with those sets. Then you have to verify actually. So let us write the other laws here. Next law number 5. The distributive law. One of the most handy laws here. Suppose A, B and C, I am not writing, A, B and C are three any sets, then A union B intersection C. So this intersection will be distributed with union. Just see how it is coming. A union B intersection A union C. So just see, this union is being distributed over B and C with the help of the intersection. So this is called the distributive law. Another law is there, that is the union will be, the intersection will be at the outside of the bracket B union C. In the same law actually, here the intersection is being distributed over the union. So A intersection C. So this is the distributive law. Whenever actually sometimes we have to prove that this left hand side is equals to right hand side. For proving those also, those are required. Some questions are there, you will just find at your exercises, that is those questions are there. Left hand side, you have to take that left hand side. I will prove some questions, 1 or 2 examples I will say you. That time those laws will be helpful to you. Number 6, one of the most important law of the set theory, that is the De Morgan's law. De Morgan's law. One great mathematician was there, De Morgan. He has invented this law, introduced this law, that is the law of complement actually. A union B complement equals to A complement intersection B complement. Number 2, A intersection B complement equals to A complement union B complement. Very, very interesting law of set theory, the De Morgan's law. Actually, for doing sums, that is okay. You have to prove. There are also the proofs. I will just do the proof here. That is, this equals to this. How to prove, and this equals to this. Only one I will do. So these are proofs are there, and also obviously the other things, that is with the help of De Morgan's law we can do solve some problems. But this law is very much important for a structure to prove that is a set, that is a system of set. In my research works also, whenever I need to describe a new set, that is the multiset, the new type of multiset, or other fuzzy sets are there, soft sets are there, we need this law. If we can satisfy with the conditions whatever we are doing, the soft sets or the multisets, the membership grades, whatever it is, so if that satisfies this one, De Morgan's law, then we can definitely say that is this law, this is the structure, this is the set, this is satisfying the set, all the rules of the sets actually. So for also proving the new structures as a set, we can have to take the help of De Morgan's. So it is a very important rule. Okay, now let us write some rules and then we will come to the proof of De Morgan's. It is very important also for the exam purpose. Now let us just know about some simple rules where sometimes for solving the problem those are required. Very easy rules actually. I think the previous one it was number 6. So number 7, that is A complement and then complement, so equals to A. That means you are taking A complement, that means universal set minus A, and then again its complement. So we are coming to the original set only. Now for the complements, two results are coming at my mind. That is universal set, the complement of universal set. So what it is coming? Complement of the whole thing, that is phi only. And number 9, the phi complement, it is coming the universal set only. Number 10, A intersection A complement. So A is there, the common part of A and the set, universal set minus A, that set and also the A. So what it is coming? Nothing it will come. So it is coming phi, that is the null set. Number 11, the similar thing, A union A complement, that is A is there and union of the set, the portion of the universal set apart from A. So that means this is like that. This is the set A and this is the universal set minus A, that is this part. So this union this one, that means we are getting the total universal set. So here it will be the universal set. And number 12, I have told I think that previously, but also here I am writing, that is A, if A is the subset of B, both side implies that is B complement is the subset of A complement. In well defined rules, you have to keep in mind, sometimes there in exam it can come, that is you have to prove those also. Proofs are very much easy, not only those can come, those are very much easy. Okay, so those are some rules, some handy rules, and also some corollaries are there, some addition and subtraction of the rules, that is the combination of the rules are there also. So you will find those at your book, no problem. Those also you can find at your book actually. We need to take the class, and also sometimes you can think that is why those rules are there, that's why I am taking this class actually.